everyone. In this video, I will continue to work on exercises to review for quiz 2. In the previous video, I worked the examples 1 through 11, and in this video, I will continue from 12 and all the way through. So in question 11, we are asked to reduce this fraction to the lowest terms. So to do that, we want to factor the numerator and the denominator, and then we're going to be looking for common factors so we can cancel them out. So let's look at the numerator, which is 4x minus 16, and we're going to find the greatest common factor, which is 4. And then we're going to pull that out. Then we're going to find out the quantity that will multiply 4 to get us to 4x minus 16. So 4 is multiplied by x to get to 4x. So the first term in parentheses is x. Then here we have the minus that corresponds to the minus right here. And then pulling out 4 from 16, we're left with 4. So the numerator factored is 4 times the quantity of x minus 4. And the denominator, we're going to factor using the trial and error method that we used before. So we're going to write that as a product of two binomials. We're going to break down as x squared as x and x, because x times x is x squared. Then we're looking at the factors of negative 8 that add up to negative 2. So since we have negative 8, we're looking for a positive and a negative number. So let's say plus here and minus here. So factors of negative 8 that add up to negative 4 will be negative 4 times 2 equals negative 8, and negative 4 plus 2 equals negative 2. So the pair of numbers that we'll be looking for is negative 4 and 2. So 4 goes with a negative and 2 goes with a positive. So notice here that the numerator has an x minus 4 and the denominator has an x minus 4 as a factor. We cancel that out. Then we're left with 4 over x plus 2. Example 13. We're also asked to simplify here. So with the same principle, we're going to factor the numerator and the denominator and try to cancel the common factors. Well, the denominator is simple and also factored, so we bring it over as it is. Then we're going to factor the numerator. So we're looking at 56. Let's write that as 7 times 8, and 63. Write that as 7 times 9. So we see that 7 is a common factor of 56 and 63. And between x to the third and x to the fifth, x to the third is a common factor because x to the fifth is x to the third times x squared. So the greatest common factor then, greatest common factor of the numerator is 7 times x to the third. So we're going to pull that out. So let's have 7x to the third, and let's find out what's left after we take that out. So 56x to the third divided by 7x to the third, we're left with 8 minus 63x to the fifth divided by 7x to the third is 9x squared. Let's fix this. 9x squared. So let's check real quick. 7 times 8 is 56 times x to the third, the first term. 7 times 9 is 63. X to the third times x squared is x to the fifth. Then the next step is to cancel out common factors. So remember, we cancel them only when we're multiplying. So we have all these factors, and we see that 7 will cancel with 7. X to the third and x is going to give us x squared on the top. X to the third divided by x is x squared. So then we're left with x squared times 8 minus 9x squared. In this example, we're asked to find the product. The common mistake that I see students make here is they go ahead and say 8x plus 9, all of it squared. I'm going to do here this on the bottom. 8x plus 9 squared equals 8x squared plus 9 squared, which would be 64x squared plus 81. Not correct way. Okay, so let's see what this is step by step, and then we'll talk about why we cannot do this. So this is wrong. So not that. 8x plus 9, all of it squared is 8x plus 9 times 8x plus 9. Now we're going to distribute. 8x times 8x is 64x squared plus 8x times 9 is 72x plus 9 times 8x, 72x plus 9 times 9 is 81. Then we combine like terms. We get 64x squared plus 144x plus 81. So let's look at the difference. The wrong way would give us 64x squared plus 81, but the correct answer has the middle term right here. So make sure that if you're squaring something, the operation, when the operation is positive, you're going to multiply the binomials. You cannot just go straight and square the terms. Let's move on to the next example. We're asked to simplify by rationalizing the denominator. Rationalizing the denominator means no radical in the denominator. No radical in the denominator. Okay, radical means square root, third root, and so on. So what I'm going to use here is the difference of two squares, and I'm going to write the formula here on the bottom. Remember, if we have a plus b times a minus b, and if we multiply this, we get a squared plus ab minus ab minus b squared. So we'll end up having a squared minus b squared. So having this in mind, because I want to get rid of the square root of 7 in my denominator, I'm going to multiply my denominator by square root of 7 minus 2. So I can use this formula that I wrote before. In order to keep the fraction the same, I have to multiply the numerator by the same quantity, square root of 7 minus 2. And then we're going to simplify. Square root of 21 times square root of 7 minus 2 times square root of 21. So I distribute square root of 21 in the numerator. Then I'm going to multiply in the denominator by using the property we wrote before. In this example, a is square root of 7 and b is 2. So the answer will be a squared, which is square root of 7 squared minus 2 squared. Square root of 21 times square root of 7 is square root of 21 times 7 minus 2 times square root of 21. Square root of 7 squared is 7 minus 2 squared is 4. And square root of 21 times 7 is 144, so that's the square root, minus 2 times square root of 21 over 3. If we're looking at square root of 144, I think 49 goes into it, so let's simplify that radical. 44 divided by 49. Okay, so when I multiplied 27 times 1, that is 147. So let's fix that error. $147 and 49 goes into 147 3 times, so we can write that as square root of 49 times 3 minus 2 square root of 21, all of that over 3 equals, square root of 49 is 7, so that is 7 times square root of 3 minus 2 square root of 21 over 3. Sorry about this, I ran out of room here. So the answer to our fraction in the rationalizing the denominator form is 7 times square root of 3 minus 2 times square root of 21 over 3. In this problem, we're asked to find the degree and the leading coefficient of this polynomial function. So the first thing we're going to do is we're going to write this polynomial function in standard form, which means that we're going to write the degrees of x in decreasing order. So we're going to look at the highest degree here is x to the 4th, and here's the term, so that's going to be first. So 3x to the 4th, and then the next degree down is x to the 3rd, so minus 6x to the 3rd, minus 10x squared plus 5x, here's 5x, and then minus 7. So this is a polynomial in standard form. The leading term is the first term, 3x to the 4th. Leading coefficient is the constant that multiplies the power of x. So in our case is 3. And degree of this polynomial is 4, which is the degree of the leading term. In this exercise, we're asked to simplify. Recognize that we have a big fraction. The red line divides us the numerator and the denominator. And in numerator and denominator, we have fractions. So I'm going to look at all the terms as fractions. So x as x over 1. So in order to simplify this, we can go in different routes. The way I'm going to go here is I will write the numerator and the denominator in the simpler form. So I will write the numerator as one fraction. So we're going to add those fractions. So we have x over 1. We're going to multiply by x plus 4 to convert the first fraction into the denominator x plus 14 actually. X plus 14. Multiply the numerator by x plus 14 plus 49 over x plus 14. We're going to do the same thing for the denominator. So we have x over 1 times x plus 14. So what I'm trying to do is make the denominators the same. Times x plus 14 right here, minus 14 plus 49 over x plus 14 equals, let's combine the fractions, x times x plus 14 plus 49 over x plus 14. In the denominator, we have x times x plus 14 minus, I'm going to put the expression in parentheses because I have to subtract the whole quantity in this numerator. So minus 14 plus 49. I missed an x here. So 14x. Let's fix this. 14x plus 49 over x plus 14. X squared plus 14x plus 49 over x plus 14, and in the denominator we have x squared plus 14x minus 14x minus 49. Distribute the negative into each term over x plus 14. Okay, so now we have a fraction over a fraction. Let's convert this into a multiplication while we combine like terms as well. So x squared plus 14x plus 49, that is that numerator over x plus 14 times the reciprocal of the denominator, which is x plus 14 over the 14x and negative 14x will cancel out, x squared minus 49. Observe that we have x plus 14 will cancel out with x plus 14 because we're multiplying these two fractions. And x squared plus 14x plus 49 factors into x plus 7, all of it squared. And x squared minus 49 factors as x minus 7 times x plus 7. So after we cancel out the x plus 14, we're left with x plus 7 squared over x minus 7 times x plus 7. And in here, we have x plus 7 squared, which is x plus 7 times x plus 7. So one of these is going to take away the x plus 7 on the bottom. So then we're left with x plus 7 over x minus 7. Recognize that we have a fraction here, so we need x to be different from 7. And because we have x plus 14 in the denominator when we started with, we need x different from negative 14 as well. We're multiplying two complex numbers, so we're going to distribute this similar to what we've done before. So we're going to have 3 times negative 4, which is negative 12, and distribute 3 into negative 8i, which is negative 24i, and then positive 7i times negative 4 is negative 28i, and 7i times negative 8i is negative 56i squared, equals negative 12. We combine like terms, the negative 24i and negative 28i, which will give us minus 52i minus 56. I squared is negative 1, and that's what I'm going to substitute it with. So minus 56 times negative 1. So we have negative 12 minus 52i plus 56. And then combine negative 12 with positive 56. And that is 44. And then we have minus 52i. Here's another fraction we want to simplify. So the red line separates the numerator, which is a fraction, denominator, which is another fraction. So we're going to convert this into a multiplication. So the numerator, which is 147 times a over 2 times the denominator flipped. So we have 4 over 7a to the third. We can simplify 4 and 2 into 1 and 2, because 4 is 2 times 2, so we take one of the 2's out. A and a squared will give us a squared in the denominator and 1 in the numerator. 7 goes into 147, 21. Let's check that real quick. 147 divided by 7, that's 21. So the 7 and 147 will be left with 21 and 1. So lots of simplifying here. So then we have the line for our fraction. The numerator we're left with 21 times 1 times 2. And denominator 1 times a squared, which will give us 21 times 1 times 2 is 42. And denominator is 1 times a squared over a squared. Here's an application of the algebra we've been doing here. So a garbage incinerator charges $45 plus $30 per ton. The average cost per ton is given by AN equals 30 times N plus 45 divided by N, where n is the number of tons. So whenever we work with word problems, we got to make sure we understand the variables. So in our case, AN is the average cost per ton, and N is the number of tons. The first question is, based on the graph, is AN increasing or decreasing? So if we increase the weight, what happens to the average cost per ton? Or if we look at the graph over here on the top right, and we're going to study the graph when we're increasing n, so we move n on this direction. That means that I go from 0 to 1 to 2 to 3 to 100 to 1000. So if I increase n, what is happening to the average cost? So if you look at the graph moves from the top down to the right. That means that the y values are increasing. Let's say this again. As we move to the right on n, we see that the graph is going down to the right. That means that the y values are decreasing. So in this case, AN is decreasing. As n increases. On question 2 of number 20, we're asked to calculate the average cost per ton for 3 scenarios. The first scenario is when we have 10 tons, the second scenario 15 tons, and the third scenario 19 tons. Well, the equation is AN equals 30 times N plus 45 over N. So in order to calculate our average cost, we're going to plug into the equation the number of tons that were given. So here's scenario 1. N is 10. So we're going to plug in 10 into the equation. So we're evaluating A of 10. That's going to be 30 times 10 plus 45 over 10. N is 10. Let's simplify this. 30 times 10 is 300 plus 45 divided by 10. 345 divided by 10. That is 34.5. Let's not forget the units. So this is measured in dollars because it's the average cost. The second scenario, we're given N equals 15. So we're evaluating A of 15. So into the equation, we're going to plug in 15 for N. So 30 times 15 plus 45 over 15. So again, 15 is the N that I'm plugging in. Let's simplify this. 30 times 15 is 450 plus 45 over 15. 450 plus 45 is 495 divided by 15. Let's find out what that is. $33 and 0 cents, so $33. And the third scenario, N is 19, so we're going to plug in 19 into our equation. So A of 19 equals 30 times 19 plus 45 over 19. So recognize 19 is what I plugged in, equals 30 times 19 is 570 plus 45 all over 19. 615 over 19. Let's find out what that is. $32.37. 32.37, so I rounded it to the nearest cent dollars. So this is the last exercise to review for this quiz. Have a good day.